Okay, so when you run a regression, and this is just a simple regression because you've only got one variable in here, what you are going to get is your very first table is going to give you a model summary. Okay, so you'll notice in your model summary, it actually tells you down here your predictors. You've got a constant and you've got an advertising budget, and I'll show you that here in a moment. But the two things you want to look at is your R value, and this R value is the relationship between sales and advertising budget, and your R squared is how much advertising budget contributes to sales. So 33% of advertising budget contributes to sales. So 66.5% is due to something else. Okay, so that's your model summary. Just be thinking about this. The smaller this value is, the less that those variables are related. Okay, so the next piece that you get is an ANOVA table. So earlier in the notes, we talked about the SST, SSR, and the SSM. Those are those values right there, which you can actually look for bias, and you could use those to calculate certain variables. We don't worry about it too much, but the very important thing you want to look for is right here. Okay, and you want to look at your F value and your significance value. And in essence, what this is telling us, if this value is significant, so how do we know it's significant? If it is less than 0.05, then what this means is that our model is a better predictor of sales than just the mean value of sales. Okay, so it's telling us that advertising significantly contributes to the album sales. All right, and then you go to your very last coefficients table. Notice I've crossed this out just because your SPSS version that you have may not have bootstrapping. I don't know if the ones that you guys purchased has bootstrap. I don't have bootstrapping on mine, so I just don't talk about it. So we'll look at the first one up here, okay? And so what you want to be looking at is these unstandardized coefficients. These are your B values or your beta values. All right, so when you think about your equation, I'm going to come back down here, and I just use y is equal to mx plus c plus or minus error. But again, going back to the earlier pages, you had y is equal to b0 plus bx1 plus bx2 and so forth. It's the same thing. Okay, and in this case, we are going to predict album sales based on advertising, and then there's going to be a value, and you're going to have a constant and your error. So if we were to plug this in, so if we said if they spent no money on advertising on their sales, then their sales would be 134,140 albums. Okay, and where do I get this number from? It is this beta constant right here. All right, so you can plug in the math, and you can say they spent zero money. All right, zero money on adverts times 0.096. Where do I get 0.096? It's this value right here that's associated with advertising budget. All right, and you multiply those and you're going to get zero, and so ultimately you're left with the constant. Okay, another important piece to look at when you're looking at your model parameters is you want to look at your t value and your significance value of your predictors. So here we've only got one predictor in here, and it is significant, and this significance being less than 0.05 tells us that the predictor variable is a significant predictor of the outcome of album sales. If this number was greater than 0.05, then we would say advertising does not contribute significantly to the sales. And then one last slide here, just so you can see again, going back to Andy's example, he uses the betas. 134, it's the exact same thing I did, times the advertising budget. So let's say, for instance, we had $100,000 that they spent on advertising budget. What that does is it then predicts this is how many albums we'll sell. And again, I think this is in hundreds and thousands. All right, so 143,740 albums will be sold if we spent 100,000 on advertising budget versus in the previous example, if we put 0, this is how many we're going to sell is 134. So hopefully that makes a little bit of sense on your prediction and gives you some idea how to use linear regression. And this is a simple linear regression, meaning we only have one predictor variable.